So welcome back guys to its runtime. Till now we have completed 20 questions from this sheet, and today we will be covering last 5 questions from this array questions, that is 21 to 25, and from next video we will be studying the string questions. Okay, so let's see the question. So the 21st question is, find the equilibrium index of an array. Now what is the equilibrium index? Let's say we are given one array 1 2 3 2 1. So the equilibrium index will be the index from which the elements of the left subarray and the right subarray is equal. Let's say the left subarray is 1 and 2. The sum of elements is 3, right? And the subarray, right subarray is 2 1. Sum is 3. Both are equal, right? So we can say this 3 is the equilibrium element and the index is 2, right? So this is the index. We need to return this. Now we need to find the left subarray sum and the right subarray sum. How can we do this? First way is the brute force. We can traverse the array, and for each index we can find the left sum and the right sum, right? That will take O n square time complexity. Now can we optimize this? Yes, we can. How? Let's say our array is 1 2 3 2 1. This is our array. We can find the total sum. Let's say total sum will be 1 2 3 3 6 3 9. 9 is the total sum. So for each index we will traverse the array, right? And for each index we will track the left sum. Let's say we are here. What is the left sum? It will be 3, right? We are traversing and we can track the left sum, and for each index we can find the right sum also. How? We can simply subtract left sum from this total sum, right? So we can, from the total sum we can subtract this left sum, that is 3. We get the right sum, that will be 6, right? This is 6, correct? So at any index, we if left sum is equal to the right sum, okay, right sum, that means this is our equilibrium index. Okay, so when it will get to 3, the left sum will be, what will be the left sum? That is 6, and the right sum will be 3. Okay, now we need to subtract this current element also, right? We need to subtract this from the 6. So it will 3, right, minus 3 is the left sum and 3 will be the right sum. So this is the equilibrium index. Okay, so let's write the code. It's simple only, right? So let's say we will be having one function as find equilibrium index. We will be given one array, right? Let's say ARR. Okay, now in this first we will be calculating the total sum, right? So int total sum, initially it will be 0. Now for each loop, int num on this array, given array, right? So we will be adding total sum plus equal to num, correct? Now we got the total sum. Now we need to traverse the array 1 2 3 2 1. We need to traverse the array, and for each element we should track the left sum and find the right sum, correct? Okay, so int left sum, initially it will be 0, and we will start for loop from int I equal to 0, I less than array dot length and I plus plus, correct? Now we will get the right sum. How? Simply subtracting the left sum from the total sum. Total sum minus left sum minus array of I, right? Okay, so from the total sum we will be subtracting the current element also, right? That's why we will get the left sum or right sum, correct? Now if left sum equal to right sum, that means we got the answer. We will return this index, that is I. Otherwise we need to add the current element in our left sum. Left sum plus equal to ARR of I. Okay, so that's it. And if it's not there, we will return -1. Okay, so let's start again. We are given 1 2 3 2 1, right? So we will start from index 0. We will start from here. What is the left sum? Left sum is 0 because nothing is there before this element, so it will be 0. Now the right sum will be total sum, that is 9, minus left sum, that is 0. It will be what? It will be 9 minus the current element, that is 1. It will be 8. Okay, so the right sum will be 8. Okay, now we will go to the next element, that is 2. Now the left sum will be 1, right, because we added it here, right? So it will be 1, and the right sum will be 9 minus 1, right? 9 minus 1, that is 8, minus current element, that is 2. We will get 6. Okay, now this part is 6. This part is 6. Now we will go to the next element, that is 3. Now what is the left sum? Left sum will be 2 plus 1, 3, right? 3. And the right sum will be, that is 9 minus, what is the left sum? Left sum is 3. We got 6 minus current element, that is 3. We got the result 3. So the right subarray sum is 3 now. And we got the condition, this one, left sum is equal to the right sum. We will return I is 2. Okay, so that's how we will do this question. We will be having our total sum, and we will be tracking the left sum and the right sum. Okay, so this is the first question. Now let's check the second question. Now the second question is, find the circular rotation of an array by k step. Now this is the same question as we did in the last video, that is the 20th question. You can check out, it's the same question, right? So let's move to the next question, 23rd. Sort an array according to the order defined by the another array. Okay, so we will be given two arrays. Let's say int a will be let's say 2 1 2 5 7 1 9 3, okay, and 6. That's it. And array b will be there. Let's say 2 will be there, 1 will be there, then let's say 8 will be there. Let's set 8 also, 8 and 8. Okay, and what else? 3 will be there. Let's say this is our two given arrays, right? Now we need to sort this array A according to array B. Okay, now what is the result? It will be first 2 will come. Okay, so all 2 will come from this array. That say 2. This is done. This is also done. 2. Anywhere else? No. Let's move to the 1. Now 1 will come. 1 will come. This one will come. This one will come. Another. Nothing is there. Then move to the next. 8. 8 and 8. These will come. Then next 3. 3 is there. Okay. Now it's done. Now we will add the remaining elements as it is. That is 5, 7, 9 and 6. Okay. So this will be our resultant array. How can we do this? The brute force approach can be like, we can traverse this B, and for each element we can traverse this A and add the similar elements in resultant. Okay, let's say we are starting with B and we got this 2. We will traverse all the 2's in this A and we will add it in the result. Okay, that's the first approach. It will be O M into N. Okay, time complexity will be this one. What is M? M is the size of B and N is the size of A. Okay, now can we optimize this? Yes, we can. We can use the hash map. Okay, how? See for 2, what we are doing? We are printing all the occurrences of 2 from A, right? So we can calculate the frequency of 2, right, in A, correct? So let's say 2 is there. What is the frequency? 1, 2, that's it. So there are 2 2's and then 1. What is the frequency? It's 2, right? And for 8, what is the frequency? It will be 2, right? And for 3, what is the frequency? Frequency is 1 only, right? So now we will be traversing this B and we can simply get the value. Let's say this is key and this is value, right? Now one question for you. We are calculating the frequencies, right? So which data structure should we use? Obviously hash map, right? Hash map we will use key and the value, right? Key value pair should be there and the element will be the key and its occurrences, that is frequency, is the value, right? So we will use the hash map. Now come to the logic. We will traverse each element in B and we will check if it's present in the hash map. If it's present, then we can get the value of that element and we can run the for loop, right? Let's say it's 2, so we can run the for loop 2 times and add that value in the result. Okay, so we will add basically 2 times 2 in our result, correct? Same with 1. The for loop will run 2 times and it will add the value in the result, correct? So this is how we can do. After that we can add the remaining elements, right? So let's write the code. So we will be having, let's say, the function sort by order is the function, and in that we will be given one array, sorry, 2 arrays, that is array A and array B, right? So now we will be using hash map. So let's initialize that of integer type, integer comma integer, correct? Now let's say its name is frequency of A, right? New hash map. Okay, it's there. Now we will add each element from this A in the hash map and its frequency, right? So we will apply the for each loop here. Let's say int num to A. Now we will check if it's present or not present. Frequency A dot put what num, and we can get the value using the get or default method, right? So frequency of A dot get or default, get the value of num. If it's not there, it will take 0 as default value. Otherwise, if it's present, then it will take the value of this key, and then we will add +1. Okay, so this that's how we will add the frequency of each element in hash map. Now frequency is done. Now we will traverse the B array and we will use the hash map to get the value, and using that we will add the values in the result. Okay, so let's initialize our result first. Integer type result equal to new array list. Done. Now we will traverse the array B. int num, not num, let's say it's b from b. Okay, now we will get the value from this hash map. Okay, so if frequency of a dot contains key what b, if it's there, then we will get the value and run the for loop to add the values in this result. So for loop will be there, int I equal to 0, I less than what its value, right? So frequency of a dot get what, get b, it will get the frequency of b element, how many times it occur in array a, right? We need to add that frequency only in result. So I plus plus, let's say here 2 comes 2 times, right? So in the result also we need to add 2 times. So I plus plus, then what we need to do, we need to add the result, we need to add the element in our result. Okay, so result dot add b, right? So that's it. After that, after adding all the elements, we will remove that element from the hash map. Frequency a dot remove b, right? Okay, why we are removing, because at the end when these elements, let's say these elements are done, then we need to add the remaining elements also, right? Let's say 5 is there, 7 is there, 6 is there, right? So these are present in the hash map. So when these elements of b are done, we will traverse the hash map and add the remaining elements. So now we are done with the elements of b. Now we need to add the remaining elements, right? So we will traverse this hash map and we will get the remaining elements, right? So for we will use the for each loop on this hash map, that is frequency a dot key set. Basically it will give all the keys present in hash map, then we will get the value of each key. So for each for loop we will apply like this only. Okay, equal to 0, I less than what, frequency of a dot get key, right? Then I plus plus, then we will add the element in our result. Add what, add key, done. So at the end we will return the result. So that's it, guys. Yeah, so this is the solution. Now here, what is the time complexity? Time complexity is O m plus n. Okay, n is the size of a, m is the size of b, right? So this for loop is checking O of n, right? And this for loop is checking O of m. Now you will be saying there is another for loop in this for loop. So now what is this for loop is doing? Basically it's covering all the elements of array, right? So in total it will be on, right? In the worst case, right? In the worst case, when all elements will be there in b and in a also, then it will take of n, right? It will cover all the elements from a, right? So in total it will be on, not for the single element in b, but in total it will be on. So it will be o m plus o n only, right? So this for loop, this is checking of m, and this is in total is checking of n. So we will add it. Okay, why we are adding? Because it's in total, not for a single element in m, right? So that's it. Let's move to the next question. So the next question is search for an element in an array. Okay, this is simply search algorithm, right? So basically first we need to ask the interviewer if our array is sorted or not. If it's not sorted, let's say 4 3 1 5 6 something like this is given, and we need to find the element k, let's say 5, then how can we do? We can simply use the linear search. That means simple for loop we will apply on this, and we will check if our elements is equal to k. If it's equal to k, then we will return the index, right? So this will be the simple for loop from I equal to 0, I less than its length, let's say array dot length and I plus plus, and we will check if array of I equal to k, then we will return I, otherwise at the end we will return -1, that means not found. Okay, so this is the linear search when our array is not sorted. Now if array is sorted, we can use the binary search. Binary search, what is the time complexity of binary search? It's O log n, right? For the linear search, it's O of n only, right? We are traversing the array. Now here, what are we doing in binary search? Basically we are using the while loop. Let's say if our array is 1 2 3 4 5 6 and 7 and 8, let's say this is the array, and we need to find the element 6, right? So what we will do, we will apply the while loop. Okay, we will find the mid first. What is the mid here? What is the mid here? This will be the mid, right? 4 will be the mid. Now we will check if our element is smaller than mid or larger than mid. In our case it's larger, right? So we will update our low. Initially low will be here, low will be here, and high will be here. We will get the mid element by this formula, high minus low by 2. We will get the mid, correct? Now we will check if our k is smaller or larger. If it's larger, then we will update our low. That means we need to search in this window now. Okay, so our low will be mid now. Now again we will calculate the mid. Now mid will be this one, 6. Now again it will check if our mid is equal to 6, that is k, or not. In this case it's equal, so we will return the I. Okay, so let's say if k is 2, k is 2. Now k is smaller or larger than our mid. It's obviously smaller, right? So we will update the high because we need to check this window now. Okay, we need to check this window, so we will update our high. Now high will be our mid and low was the same. So now mid, what is mid? Mid will be 2. Again it will check mid is equal to k. It's equal, so we will return I. Okay, so that's it. Let's write the code for this binary search. So we will be having the function name binary search. Okay, we will be given one array, that is, let's say array, and target will be there, let's say k. Okay, so low will be there, and low equal to 0, and high, let's say high is last index, right? Array dot length -1. Now we will apply the while loop while low is less than high. Okay, and in this we will be calculating the mid, and mid equal to, now what is the mid? Let's say 1 2 3 4 5 6 7. Now in this case this is the mid, right? But in the next traversal, when low will come here, how we will find the mid? High. Okay, so we can't find using this formula, because what it will give, it will give 6 minus 3, that is 3 by 2, it will give 1, right? But our mid is this one. What is this index? This is 3, 4, right? This is 4. So basically we need to add low here because it will give the mid between low and the high, and we need to add low also because it will give the exact index in this array, right? So we will add low, that is low is 3 plus 1, we got the index, mid index. So low plus high minus low by 2, right? So this will be our formula for mid. Now we will check if our mid is equal to k, that is our target, then we will return what? We will return the mid element, right? This is the element. So here we need to put array of mid, right? Because mid is the index. Okay, now again we will check if else if, okay, else if array of mid as smaller than the target, that means we need to update our low or high. Let's say if mid is smaller, that means 4 is smaller than 6, we need to update the low, correct? So low equal to what? Mid, right? Mid plus 1, we need to take this element from this element, right? So that's it. And in the else if mid is greater than k, then we will update the high, right? High will be mid minus 1, correct? And at the end we will return minus 1 if nothing is returned, right? That means our element is not in the array. Okay, so the time complexity for binary search will be of log n. Okay, so that's it. Let's move to the next question. That is the last question. The question is, check if an array is subset of another array or not. So we will be given two arrays, that is int a. Okay, let's say it's what, 1 2 3 4 5, and one subset will be given, let's say b, let's say 2 comma 4. Okay, so we need to find if this subset is, if this array is the subset of array a or not. Okay, so what are the subsets from this? It will be anything like 1 comma 2 is the one subset, 2 comma 3 is one subset, 2 comma 4 is one subset, 2 comma 5 is 1. So there are 2 raised to power n number of subsets from this array. Okay, now we need to check if this array is a subset of array a or not. So how can we do? We can simply check if these elements are present in array a or not, right? So we can check 2 is present, 4 is present, so we can say yes, this is a subset of array a. Okay, now this is the case when we are having the unique elements, right? Let's say we are having array like this, 1 2 3 4 comma 4 comma 5, right? And int b 2 comma 2 comma 4, right? So is this is a subset of array a or not? No, it's not, because 2 is there, 2 is there, 4 is there, 4 is there, another 2 is not there, so we can't say this is a subset. Okay, we will return false. So we need to check the occurrences also. Okay, occurrences, or we can say frequency. Now frequency word came, what we will use? We will use hash map. We will store the frequency in the hash map, and we can simply get it and reduce the frequency, right? So how we will do? Let's say we are traversing this 2. Okay, this 2 we will check if it's present in the hash map or not. in the hash map we will store the occurrences of elements of array A, right? So let's say for 1 it will be 1, for 2 it will be 1, for 3 it will be 1, for 4 it will be 2, right? For 5 it will be 1. So we will traverse this array B and check if this element is present in hash map or not. If it's present, then it will reduce the frequency from this array. Okay, let's say we are traversing this 2, then we will get it here, right? So we will reduce the frequency, it will be 0 now. Okay, so now it will move to the next 2. Again it will check. Now frequency is 0, that means it's not present, so we will return false. Let's say it's present, let's say the frequency was 2. Okay, now after this it will be 1, and when it will come to second 2, again it will get, again it will go to the 4, again it will check and reduce the frequency by 1. Now array B is completed and we will return true. Okay, so in this way we will do this question. Let's write the code. So initially let's say we have function subset, so we are given 2 arrays, right? Int A, int B, right? So we will store the occurrences of A in hash map, right? So we will make the hash map, let's say map of type integer, right? The frequency equal to new hash map, correct? Now we will traverse array A and num of A, and we will put the values, the elements, and this frequency map. Frequency dot put what num, and we will get its value if it's present, already present, by using get or default. Okay, so frequency dot get or default for which element? Num is the key. If it's not present it will take 0, otherwise it will take the value of num, and we will add +1. Okay, so in this way it will store the frequencies of each element in A. Now we will traverse the array B, right? So for each loop we will apply on B. Now we will get the value and we will reduce the frequency from this frequency map if it's present, right? So first we need to check if it's present or not. If frequency dot contains key, let's say if it's not present, then we will simply return the false. Okay, contains key what? Num. If it's not present, then we will say, or what is the second case? See, here we did, right? Here we got 0, its frequency was 0. So if it's 0, then also we will return false, right? So we will apply the OR case here, or the frequency if it's present and the value is 0, that means the frequency is 0 of num is equal to 0, that means it's not present, and in this case we will return false, right? And what is the second case? In the if it's present, we should reduce the frequency, right? So frequency dot put what? The element, the key is num, right? And we will get the value and subtract -1 from that. Dot get num -1 from that. We will decrease the frequency. At the end we will return, if it's not false then it will be true, right? So that's it. This is the solution. Now the time complexity is of n plus m, right? Where n is the number of elements in A and m is the number of elements in B, and we are also using the hash map, so space complexity will be of n, right? The number of elements in array A, right? So that's it. So now we have completed the arrays question. From the next video we will start the string questions. So there are 18 questions in total, so we will cover 5 by 5. So be consistent, and if you have any doubt, leave a comment. I will surely get back to you. Thank you, and be consistent.